All right, we're back. We are MAPD124 in the winter 2017 semester, and we are week 8, part 1 of our broadcast. Today, we're doing something different. We are doing some graphics and drawing with iOS. So we're going to talk about some of this stuff, some new stuff. Well, first of all, welcome back for your break. That means yesterday was your first day back. Did you guys relax at all? No? You guys have things to do for this week? Yeah. So I know you guys are all busy, plus doing other things. I didn't rest either. So not to say that matters to anybody, but it's just, I was one of those people that continuously is going crazy. But it's okay. So this week we're going to do a little bit of graphics and drawing. And next week we're going to get into the SpriteKit SDK, where we start doing a little bit of games. It's part of the book. With iOS and Swift, right? This is a difficult section because people don't understand graphics, A. B, they don't understand games, right? And we have trouble doing regular things with iOS, and doing games with iOS is going to be even more difficult, right? So this is where the advanced stuff is finally in, which we should have done. This would have been like lesson 1, right? So equivalent. So let's talk about this a little bit. This is a busy slide, but basically what we're doing is what we're going to be talking about is, so far we've been using the UI kit for everything. All the views are the standard views that we've been using with that are built into UI kit, and today is going to be the first time we're going to actually do something with other kinds of views. All right. So we're going to use something called Core Graphics. Core Graphics, and that's why it's CG. Don't think about it as computer graphics. It's CG's Core Graphics, right? It's primarily a C library. Oh, again, love this one, right? So I mean, it's like we're using Swift, like always, but combining it with Objective-C, right? And it's what's going to happen more and more. You're going to see a lot of this happening because there is no clean Swift for every part of iOS development. Like we saw the week before we did our exam, right? We saw that there was a lot of Objective-C involved in doing any kind of persistent storage, right? And it's the same thing here. We're going to use a little bit of C. We're going to talk about how that works and a little bit how it's different than standard Swift. Not as bad in this case. We're going to use something called Quartz 2D. And Quartz 2D is an API which allows us to tap into the core graphics framework that's part of iOS, right? So core graphics allows us to draw. And I want you to think about when we draw with core graphics, we use something like a canvas. Now, has anyone ever done anything with HTML canvas, maybe? No? If you guys use HTML canvas, you have a tag in HTML. It's the canvas tag. And it's a container, and what you do in that container is you define a width and a height for the canvas, and that canvas is an area of the screen that you continuously refresh. You draw, it's like a dry erase board. You draw onto it pixels, and then the next frame it refreshes, and there's new pixels. The canvas. It's like you're drawing in real life. Okay? So the whole idea of this painter's model, which means like where you're going to use some commands to paint, we're going to apply to the canvas, and then they're going to disappear. That's what it's all about. So what we do is in real life, when the painter paints different colors, red, let's say he paints the top of the canvas red in this example, and it paints the bottom of the canvas blue, and where they mix, where they kind of collide, the red and the blue, depending on how much red and how much blue, if it's opaque paint or if it's semi-transparent gloss, you might see from one to the other, and you're going to get a different color underneath, right? And it's the same thing when it comes to drawing with the canvas here with core graphics. So Quartz 2D, again, you can use it with not just iOS, but also with Mac OS, if you're going to draw stuff in Mac OS, any kind of drawing, or if you want to use procedurally generated shapes. So instead of using some standard shape that you get from the UI kit framework, you can make your own shape, right? And when you use your own shape, what you can do is, can make it so that your interfaces become more interesting, as opposed to, okay, I've got a standard button, I've got a standard slider, I've got a standard whatever. You make your own, and you can do that with some of the stuff that I'm going to show you today. All right, so Quartz 2D is what we're going to be using, and let's talk about how they use their their framework. So again, we have this. We might create a subclass, like it says, of UIView and add Quartz function that's called draw. Okay, and what draw does is it literally spits out pixels onto the screen. Okay, so you have a canvas. And I want you to think about, whenever we talk about a canvas, I want you to think about it as a context. That's what it's going to be, all right? Whenever we talk about context, we mean canvas. That's the word, right? So the current context is the current canvas we're drawing to. If I have a view controller, for example, I have my main view controller, whatever it is, viewcontroller.swift, and I want to draw to viewcontroller.swift, that viewcontroller.swift becomes my context, which means that's my canvas. I can draw all over it, including all over the controls that are on it. You're going to see that today, right? So that's how it draws. It uses this context as a canvas, right? All right. And I'm not going to talk too much about this slide. More or less, the stuff that's in the slide is from the book. I'm just going to go over it with you, so we're good. Again, like I said earlier, Swift mapping, we use C language pointer types, so CG context reference. We use CG points. We use CG recs. We use CG everything. CG meaning core graphics, right? So here's an example of what it might look like. You have a context. By the way, this is wrong. See this move to an add line? It's all wrong now. It's from Swift, 3.x to 3. Whatever we are right now, it's changed. The big thing with Swift 3 was this whole grand renaming, right? They renamed a bunch of stuff, and it broke everything that came before, right? Well, the book that was written, this book was written just on the cusp of when everything got renamed, right? So there's going to be some functions from the book that just don't work properly. And of course, I've had to fix them, right? Which I have. That's not a big deal. But more or less what you have is this. You have a context, and you set something called the line width, let's say to 4 pixels, right? And then you set the stroke color. Stroke color is the color that you're drawing of a line, right? Fill color and stroke color, 2 different things. Fill color would be the stuff that comes in the background. Stroke color is like the border color or the edge color or whatever you want to call it. If you're drawing a single line, that's the way you draw it. And then what you're going to do is you're going to use this UI enumeration, right? So UI red, UI color red, and then you're going to specify that it's a CG color, right? Then you're going to move it to another location, for example, X coordinate 10 and Y coordinate 10 in pixels, right? And then you're going to add line. This has changed too. There is no move to, there's move. And there's no add line to, it's just add line. And you're going to see how instead of having the coordinate systems right in here, you're going to use a new anonymous type of CG point that you're going to put in there, which we're going to talk about. And then what you do is you do the final command, which is stroke path. What it does is it takes all the different things we've just described here when we create our path to drawing everything, and it draws everything that we've kind of described here. So again, if I want to set my line width to 4, that's 4 pixels, like a 4-point border, and I'm drawing my line from 1010 to 2020. That's what's happening, right? Now, we need to talk about a couple things. So this describes all the stuff that I just said. I'm not going to go over that too much. Notice that we use move to. It's interesting that she did move to X and Y, and again, like I said, within a week they changed after this book, the code. So everything that I've kind of talked about here is the way it is. I do want to talk about the coordinate system. So the coordinate system in when we draw computer graphics is a little wonky, right? And it really depends where you're drawing. If you're using OpenGL to draw with computer graphics, then it's going to be slightly different than when you draw, with Quartz. Okay, let me show you this. So here's an example. So the 0, 0 point, if you're drawing in two-dimensional space in the real world, you'd expect it to be down here somewhere, right? X and Y coordinates would start 0, 0 down here. Not so in Quartz. It starts at the top right, top left corner of the screen, which is very common in computer graphics, right? So if you look at anything on a two-dimensional canvas with JavaScript as an example, 0, 0 point for the most part would be up here, right? Unity, no. If you're going to use Unity, it's down here. OpenGL, it's down here. And I gave you that example down here as well. OpenGL does draws from down here. So it's actually opposite. So if I go from, in Quartz, if I say go to 1010, start drawing your line from here to 2020, right? It'll draw the line for you this way, down the page, right? In OpenGL, it'll draw it up the page, right? And same thing with, like I said, with Unity. Okay, so whenever we draw stuff in two-dimensional, in a two-dimensional system, we use some kind of coordinate system, and we're using this coordinate system with Quartz 2D. So from the top left corner to the bottom right. By the way, when we go and do Sprite Kit, this is all thrown out. Next week we're going to do Sprite Kit, and you're going to go, but didn't you tell me last week, Tom, that 0, 0 was the top left corner? Yes, but not Sprite Kit's going to mess you up next week, right? So just FYI, it's not like that at all. All right, so we need these two floating point numbers, and we need to use a object of type CG point. CG point has two floating point X and Y values, and we plug those into where we're moving our pen. And I want you to think about it like this. Whenever we do drawing with this, actually it's very similar to using Canvas on HTML. It's almost like we got an invisible pen, and we tell, okay, go here, put your pen down, start drawing to here. Okay, now lift your pen up, move it over here, start drawing from here, and then you define a path that way. And before you actually draw anything, you define your entire path first with your invisible pen, and then finally you kind of execute okay, draw my path. That's what you're doing, right? And this idea is kind of contra to what we're used to, yeah.
You work with absolute coordinates?
Yes.
You work with relative from the coordinate.
Absolutely.
Talking about scoring.
I love your thinking, but it's absolute.
Absolute?
Absolute.
I was asking,
Yeah, no, it's absolute, 100%, right? Because I'm drawing actual coordinates, right? So now, how is that going to work for larger screens, right? Well, the number of pixels that I have is going to be how big my canvas is, right? At the end of the day. Now, from a depth of pixel, pixel depth perspective, it's going to adjust. Like when you start drawing and you're going to draw, let's say with your finger or a stylus or whatever you're going to draw with, the problem is when you start drawing that, you're actually drawing that depth of pixel. So it's going to be relative to the context you're drawing in. So you won't notice, the user, you won't notice the difference. But what's really happening behind the scenes, that's something that Quartz is handling for you, right? Which is a good thing and a bad thing. Because what you expect to get and what you're actually getting might be two different things, all right? All right, so that's kind of a coordinate system. Any questions around coordinate system? And I'm going to, when we talk about this idea that when we use coordinates, we start drawing from the top left corner. That means as I'm trailing right, that my X value is increasing. And as I'm going down, not up, right, my Y coordinate is increasing, going down, right? Which is counterintuitive to how we think in real life, because we always think if I go Y, positive Y, that means up, but it's actually down in using Quartz. Okay. All right, so let's go back to this. So here's an example again when we have 2 points. We have a point. We're going to draw a rectangle, and we can draw a rectangle with something called CG rect. And you might have seen that already in some of our code, where you kind of define a rectangle, right? And you have 2 elements, a CG point and something called CG size. CG point, again, is just anything with CG in front of it is C code. Okay, that's what I want you to think about, right? We're accessing some C code, a C function, right? And here we go. We have CG point with an X and Y coordinate, and CG size, you'd have width and height. And they're both floats. Actually, they're CG floats is what they are, which are a little different than regular floats. All right, and then what you do is when you want to build your rectangle, you plug in your starting point, which is of type CG point, and your size of rect, which is of type CG size, and then you plug those into the method, right? Could I take this whole thing here and put it here? Sure, I could. So without actually defining a variable, I could just put it in here, okay? But this is much clearer to look at, right? You can see what this is. You can see that this is how it's done. So if I want to draw a rectangle here, I'm going to start drawing at 1, 1. 1, 1, going back to my coordinate system, is probably somewhere up here, right? And then, right, if I go back to that, to what I'm drawing, we'll go back to where that code is, here. And I'm going to draw, my width is 10, that means 10 to the right, and my height is 10, which means 10 down. And that's going to be a little, well, it's not really a rectangle, it's a square, right? Square shape, 10 by 10, roughly. And, you know, using this CG rect to draw it. So there's some tools. The good thing about using Quartz, and I'm just going to show you some tools today, there are a ton of functions that you can use that are built in, that you don't have to try and calculate angles or any of that stuff, right? Which is a good thing. You don't have to do heavy-duty math to draw a shape on the screen. Like, for example, an ellipse. It'll just draw it for you, okay? All right, set stroke color. We talked about how to set a stroke color. And notice that we have to retrieve something called a CG color reference, which, again, is we have to kind of draw it out from the UI color. UI color would be the Swift part. CG color would be the seek part. So we're deriving our color from the UI color red enumeration. Okay, just a little bit of different syntax. At the end of the day, you're getting a red color. Okay, nothing too crazy. All right, color theory. This is weird. All right, some people have this idea, and I know that's really weird. You've done Photoshop before, and I want you to think about this. Does anyone know the difference between additive and subtractive type of color? So I'm in the real world. Is it additive or is it subtractive? What do I do in the real world? Think about it. So what do I mean by subtractive and additive, right? So so let's say Mona and I were in front of a canvas, and we want to paint this beautiful scene, like, for example, a beach, because I want to go to the beach this summer, right? And so we sit down, and Mona says, okay, Tom, I want you to paint the clouds over here. And I say, okay, paint the clouds. Tom, I want you to paint the, the sand over here. So I paint the sand, my color down here. And then we, kind of make a perspective. We build a nice little area, the water, it looks beautiful, some kind of mountains. I'm imagining things, of course, right? Is this additive or subtractive? What am I really doing, right? Intuitive, you're thinking additive, I'm adding. But actually what we're doing is we're using subtractive color theory, right? Because what's happening is the light, how it's hitting the page, right? It's being absorbed. Whenever I absorb anything, I subtract from it, right? An example of this, the light in real life has all the colors of the rainbow built in. Roy G. Biv, right? Red, orange, yellow, blue, indigo, violet, right? And I take all those colors, and then the color that I'm seeing is actually, I've subtracted all the other colors, right? In order for me to paint that color on my canvas. That's how it is in real life, right? Not so in computer graphics. In computer graphics, we're using additive color theory, right? The color model is additive. So I'm going to use red, and then I'm going to add green color. And I'm going to add blue on top of that. And then I'm going to get, if I add red, green, and blue, it's going to be all black, right? If I add them all, right? Actually, if I subtract them all. If I add them all, it's going to be white, which is kind of weird, right? Because in real life, if I add all the colors, I get black. But on the color and on the screen, if I add all the colors, I get white. Think about this, right? I have 3 color channels, not including alpha for a second, right? I have my red color channel, my green color channel, and my blue color channel, right? And my red color channel, if I turn it all the way up, right, to 255 or FF, however you look at it, right? I turn it all the way up. It's the brightest it can be, red, as an example, right? And I do the same thing with green and the same thing with blue, I'm going to get white. But if I actually, if you and I go paint the scene with, for Mona, right? And I put red and blue and green on the, it's going to be like black, right? That's why it's called subtractive. It kind of takes all those, it absorbs all the colors, right? Absorbs light, and I'm using all the colors to mix them together. And that's why it's the difference between subtractive and additive. So we use these 4 components with computer graphics: red, green, blue, and alpha. And the alpha channel, typically what we use it for is transparency, right? So how does one scene blend with something else? One color, one pixel blend with another one, right? So in real life, when I take 2 pixels, I'm just talking about pixels, right? And they overlap. One color is, one pixel has a certain value, right? Red, green, blue, and some kind of transparency. And I take the other one and I put it on top of it, right? What ends up happening is when I take these 2 colors and put them on top, they blend. There's different ways to blend colors, right? And if you're someone who's used to doing things with Photoshop, right, there's different ways we can do them. We can make things darker. We can make things lighter. We can do all kinds of different formulas to affect the way the color comes out on the screen, right? That's why it's additive.
Also works with like opacity, right?
With opacity, it gives you the transparent, whatever the transparency is. So for example, if I have 50% red and if I have 50% blue, and I put both those pixels together, what's my final color? Well, it's 50% both, right? If they're both opaque. I'm saying if I have 100, so my red is 100%, my blue is 100%, but my alpha channel is 50% on both. What's the color? That's the challenge, right?
Black, if you are confused like Photoshop, I mean, it would be
You take 50%, you multiply 0.5, right, times the value of your color. So if my value was, so let's say if I have my red value was 255, it would be 128 for my red, and let's say 128 for my blue. That would not be purple. That would be something else, right? Or violet. So that's the way it works. It's kind of messed up that way. And this is a great way of looking at it. If you look at, red, green, and blue colors, additive color theory in computers, we get white, right? We subtract all these colors in computers, we get black. The absence of light, the absence of color in computers, right? Whereas in the real world, I add all my colors together, take all these paint buckets and add them together, I'm going to get black or some kind of really weird charcoal gray, right? Most likely. Okay, so it's kind of different. The range of colors, I think this is important to know as well, because I can get this range. How many, by the way, for most computers right now, how many, if I have 255, 255, what's my color range in terms of number of colors for the average screen? Anyone know? The average number of colors. How many colors can I get nowadays with my average screen, even with my average phone? How many colors does it support? Is it thousands of colors? What is it? Millions. What millions is it? There's a certain number it is. 16.7 million colors, right? That's the number of colors we can actually get with a phone or with a screen, right? So you can get these values, 255, 255, 255, and if you multiply them, 255 times 255 times 255, that's a different combination of colors you can get from 0 to 255 for each channel. And it gives you 16.7 million colors. And that's called, the range of colors called the color gamut, right? All right. Some people think that red, yellow, and blue are the primary colors. And in real life, red, yellow, and blue are the primary colors. Those are the primary colors, right? But computers, again, we use red, green, and blue, right? Because that's just the way our screens work. They work a little different. Red, yellow, and blue don't work properly on our computer models, and they're much more difficult to calculate when it comes to math. When we do math on with colors, right? Like red, green, blue works a lot easier. And the other thing is there are other color models that you might have seen. For example, hue, saturation, and value, hue, saturation, and lightness, and the one that we use for print, which is CMYK, right? Cyan, magenta, yellow, and black, K being black, right? And we use that for print. Anyone ever do print? Any kind of posters or any kind of labels or anything, right? I've done labels for companies before, and every time I do anything with AI, with Illustrator, I'm always doing it with CMYK because it's spot color. It's that kind of stuff, 4-color offset for printing. Because, again, it's a different kind of color. If I'm printing to paper, it's different than printing to the screen. So I use a different color model. And that's a challenge. So if I see something on the screen that I make with my Illustrator, and I'm using RGB, the RGB palette, or that whole color model, it's going to look different than what it looks like on print. And if you ever try and do that, if you ever try and print out what you draw, it looks totally different because the way the printers spit out the ink, right? And also, what kind of paper are you going to use to print on? If it's white glossy paper, that's going to affect, lighten the tone or of the color because of the color of the paper. The color of paper is white, then it's going to be lighter, right? A lot lighter sometimes than what we see on the screen, right? And if the color of the paper is a little darker, off-white, then it's going to be slightly darker or different color than what you see. So that's another thing that you have to think about. The absorption qualities of the paper, when a paper, depending on the kind of paper you're using, you're going to have a different situation altogether. And also, when you have to convert from RGB color model to a CMYK color model, CMYK supports different levels of color. You're going to get a difference in terms of what the color looks like as well. Okay, just letting you know. So these are the way color works. All right, so why are we talking about color? Because we're going to use colors in a second, right? All right, for this, going forward with today, I want to talk about a couple things here. One of them is I've built the app. I put it up on GitHub ahead of time. And like I said, I had to adjust it. And the reason why is because it just wouldn't work. All right, so I've had to kind of rebuild it and everything else. And so it's up on GitHub right now. If you look up on GitHub, it's under MAPD W2017 lesson 8 if you want to follow along. What we want to try and do is recreate this as much as possible. But instead of doing this and wasting our time typing and copying and pasting, I want to talk about those things. And what we do, we're going to modify the actual code a little bit here and there to see the effect, right? And we're going to talk about why things are the way they are. Okay. Let's go back. All right. So again, what we want to do is we can draw images. We can draw not just rectangles and circles and all that kind of stuff, but we can actually spit out images as well. I want you to think about these images as bitmaps. That's what they really are. Does anyone know why it's called a bitmap? Bitmap. How come? It's a bunch of bits all in a row, right, to create your your pixels, right? It defines pixels on a grid. And then depending on the pixels that are on the grid, you get your image. That's what happens, right? Each pixel, I don't want you to think about it as a pixel. I want you to think about it as a color, right? Every time we put something on the screen, we're putting a color on the screen. That's what we're doing, right? There's no pixel we put on the screen that has no color. It doesn't exist, right? Unless it's fully transparent. Like, for example, your opacity is 0, right? Or your transparency is 100%, however you want to see it, right? 1/6 of one, half dozen of the other when it comes to color, right? So we're talking about colors. I want to put colors on the screen, right? Whatever it is, whether it's on my phone or on the desktop or whatever I'm doing. Same thing with this image. The image itself is a map that defines all the pixels that are on the screen. And for the most part, most of us use a lossless PNG type image, right? JPG, right, is lossy, which means there's a compression that's been used to kind of define what the image is, and we get a lossy kind of compression. So there is pixelation. If you go really, really big with some kind of JPEG image, and JPEGs were the first ones, GIFs and JPEGs, they were the first images we started to use on the internet because they were so small, right? Because we took a huge image that's raw image format. For example, you ever try and use a TIFF image? TIFF or raw image? Those are massive, right? You take a picture, and if you take a picture with your old, like your digital camera, you go click, not your phone. Phone is not the same, but although it's very similar to this, you take a picture with your camera, and all of a sudden you get this raw image, and this raw image might be 16 megabytes, something crazy, right? And you might take it with your phone, and it might be something the same. It might be 10 megabytes, whatever. That's raw image format, right? Or TIFF. We convert it to PNG, PNG, or JPEG. PNG is lossless, right? So you get a better compression. It's smaller file. with pretty good clean image, whereas JPEG is lossy. So you actually see like some kind of artifacts or whatever when you blow it up. You can't use a JPEG for print. Impossible. And you really shouldn't use a ping image for print either, right? Because when you blow it up to make a big poster, it's usually TIFF or RAW format you want, the highest resolution possible, because when I blow it up, that 1 pixel in a TIFF, or sorry, in a JPEG or ping image is going to be 10 pixels when it's this big, or 20 pixels, or 100 pixels. And then you're going to see some really weird pixelation, like, you know, basically squares on the page, which makes no sense, right? So for print, we want the highest quality images, and that's why the print business, for rendering and everything else, they need powerful computers, more powerful than the little Mac I have here, right? Because they have to render these large images and work with them in Photoshop, right? Or Illustrator. Okay. It's a little bit of the theory behind stuff. So here's an example of this. So we have an image. This is the new variable. It's of type UI image, right? We define it as a new object. Again, there's no need for the new keyword in Swift, right? So there's the Swift part. And now here's this, the C part, right? So here's, I'm using CG point. I'm defining a point in space where the image is going to be drawn to. And then I'm going to draw the image at this point, whatever it is. Notice that the image says it's being drawn at 100, 100. How is the image being drawn? Is it being drawn from the middle, from the side? How is it being drawn? Does anyone know? Top left, the same thing. So I want you to think about it. That's very good. So when you think about it, if I look at this image, let's suppose this is an image instead of like a screen, right? Well, the image is also drawn from the top left. So I start drawing this way for the image and down, right? That's a problem, right? Why is it a problem? Because if I draw the image here, it's going to start drawing this way and down. So wherever you put it, it's not the middle of the image that you're drawing. It's that top left corner, right? So when you want to position something on the screen, you got to take that into account. If I want to set the pivot point of the image, the center point, right, wherever it is. For example, the pivot point right now by default will be that if this, let's say this thing that says Quartz 2D, let's say this thing is actually this image. It's just not text, it's an image as well. The top left corner would be the normal place to draw. And if I was going to measure this thing in terms of pixels, as an example, this is probably inaccurate. You can see that this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would be approximately at 10, right? It starts drawing at 10. And if I want to center this, and if I only have this many pixels, I got to figure out how wide is my image, because it's just pixels, right? How wide is my image in absolute positioning? Where am I going to draw it? How long is it going to draw this way? And I may have to adjust, trial and error and adjust it back and forth, depending on how wide my screen is. So be careful when it comes to drawing stuff on the screen procedurally with code, right? You may get weird effects. You might think it's being drawn here, but it's actually be drawing a little bit this way, and you may have to do those kind of things. Again, this is all theory, but we need to talk theory a little bit before we get into drawing shapes. All right, so that's the code. It's interesting that Quartz provides all kinds of functions, like it says here. For example, I can add an ellipse, I can add a rectangle, and you can define the starting point and the size, and define the origin, the kind of rect it's going to be by the starting point and size of rect. And as an example, you can say, well, here's my ellipse, and where am I going to draw it to? I'm going to draw it to the rect, and then I'm going to add the rectangle to the context. Well, I don't understand that. What does that mean? Okay, let's go over that for a second. My starting point is a CG point, right? 1, 1. My size of my rectangle, width and height, remember, is 10 and 10, so it's a square, right? The rect is actually defining a rectangle with a starting point and size of the rect. Okay, I haven't drawn anything yet. Now, I'm adding an ellipse to the rect. Why? Because even though it's drawing an ellipse, I need to have boundaries. Computers, no matter what happens, I have a square or some kind of rectangle that defines everything that I draw on the screen, right? Because there is no circle drawing. It's a square. And I'm just using that as a boundary so I can use that as for the mathematics. Then I need to draw my option, my object, right? So first I define an ellipse. I draw it to the rectangle. The rectangle is the container. I want you to think about the parent container where I'm drawing the ellipse. And then I draw the rectangle to the context, to the canvas.
So any shape other than the other shape, you always.
Well, otherwise, if I drew an ellipse to the container, it would draw to the container, whatever the container is. The ellipse itself would be a different kind of shape, but you need some kind of boundaries to define. You can't just draw an ellipse on its own. It needs to be drawn to some kind of rectangular container, right? It could be the screen. So the entire screen can be the ellipse, right? Or it could be another rectangle. And usually rectangles give me, make the ellipse whatever you want, right? So that's how you would do it. Because even an ellipse has width and height, right? But you don't have to do the heavy lifting. You don't have to think about the calculations and how to use pi to draw the ellipse and the two foci, all that kind of stuff. You don't have to do any of that thing. You just have to say, here's my width and my height of my rectangle, now draw. Right? That's good. That's the first function I like in iOS, where we don't have to draw too much, where you have to kill it so much. All right. There are some built-in demos that iOS gives you, and they give us an example here of the Quartz demo that comes with iOS, right? Apparently, you can draw all these different shapes. Okay, Quartz Fun. This is the application we're going to make, right? So the Quartz Fun application is going to have two bars, the one on the top and the one on the bottom, right? And when we define our application, we can draw with it. And I'm going to show you the finished product, right? So here's the finished product. Here I have a view controller.swift, right, like normal. We're going to talk about what all this stuff is in here. And I have a main storyboard. A main storyboard consists of very simple, these two segmented controls, one up here, and there's another one down here. Let me make this a little smaller for your screen so you can see it. There it is. And these two segmented controls, what they do is you pick the color on the top, and you pick the shape you want to draw on the bottom. Pretty simple. And with your finger on your device, right, you would draw whatever you want, okay? So how does it work? Let's run this thing so you can see it. All right, so here's our little control, and notice if I draw from here, notice how it's adjusting my line as I drag, right? And it's drawing red right now. I let go, and if I click on blue, it disappears, or as I draw the next line. It kind of clears my canvas every time I draw. I don't have to clear my canvas, but that's what it does, right? So here's blue, here's yellow, hard to see that, here's green, and here's some random color. Every time I draw, it's going to be something else. Yeah, that's what this stuff does from a color perspective, right? Rectangles. I get a rectangle with a bit of a border and a red border, or a blue border, or a green border, or some random border, right? Here's an ellipse. Again, I draw the rectangle, and my ellipse gets bound to that rectangle, right? Depending on what color I use. Notice it's just black in the middle. And here's my image, and depending on where I click, my image gets drawn. But here's something different. Notice my image has been offset. Wherever my mouse is, in this case my finger, right? My image gets drawn from the middle in this case, right? So there's a bit of an offset here. Because normally it gets drawn from the top left corner. So click my image, right? I can drag my image around, right? That's what the app does, okay? How does it do it? We'll talk about that in a second. So stop this. Again, this is all up on GitHub for you, so you can take a look at it, right? So the first thing they did was create their Quartz view or Quartz Fun View .swift file, all right? And this file is actually what they've done for this one is, and it looks pretty busy, but actually what they've done is they've made it of type UIView. So actually, Quartz Fun View is a subclass of the UIView superclass. Okay, that's what it is. Remember what UIView is. UIView is any kind of control we've used so far. Labels, we've used buttons. That's all part of the same class, UIView, right? So what this is doing is we're defining Quartz View Fun, this thing, this view, as just a subclass of the UI view. Now they've also defined a couple of enumerations, and this is how you do enumerations in Swift, right? You use the enum keyword, right? You describe the name. So here's the shape enumeration, the drawing color enumeration, and then the type. And most of the times we use int because most enumerations, we don't really care what the underlying number is. All we care about is using a friendly name to help us understand what we want to choose. When I make a finite state machine, right, I'm choosing between one choice and another. Anyone know what a finite state machine is? FSM pattern? No? I'm just talking and no one's answering. Anybody? You guys know what a FSM is? So imagine if I'm switching states. I'm switching from one color to the other. I'm switching from red to blue. Is red really 0? And is blue really 1? And is yellow really 2? No. I'm just choosing between one and another. I'm making a choice. It's almost like a menu choice, right? Well, depending on what I'm choosing, my machine, my code will switch to what I'm asking it to do. I'm asking it to do something else. And I'm using a switch statement to switch from one effect to another. Okay? Very basic, but I want you to start with that. So we're using 2 enumerations for that, and the enumerations are just a friendly name for the number. So instead of using 0, 1, 2, 3, 4, or whatever, those choices, I'm using line, rect, ellipse, and image. So we know what they mean. And same thing with drawing color, red, blue, yellow, green, and random. Okay? So we define a shape, and notice that we use the shape class for that, right? So shape is a shape line, right? And my current color is UI color.red, right? Interesting. And use random color. By default, this is just a variable that keeps track of, it's a Boolean, right? And it keeps track of if I'm using a random color or not. Okay, that's what the first things we set up on the top here. What else have we done? Notice that we're also extending, when we use the keyword extension in Swift, right? We can extend an existing class. So instead of us creating a subclass, this is interesting, it's almost like we're creating a mix-in. I'm almost kind of defining an extension from my code. I'm saying, guess what? I want to take just one function and I want to add it to this class UI color, right? As opposed to defining a whole class, a subclass, right? Based on UI color, I can use the extension keyword to define one function that I want to add on to the class, like an added or a mix-in is what it's called, right? Which is kind of neat in Swift. So that's kind of a new pattern. Maybe you haven't seen this before, right? So again, use the extension keyword, the name of the original class, UI color is built-in class. And then what we're doing is we're creating a new function, my class function, right? Random color. And my random color returns a UI color, exactly what you're getting here in the extension, right? And then what all I'm doing in this class is I'm saying the following. I'm saying, hey, let red, green, and blue, right? These variables here, or these constants, let them be to, equal to these CG floats. And notice that it says arc for random uniform, right? That's what this random color does, right? Arc for random uniform is actually a function that's built into C that generates a number between 0 and 255, a floating point number, right? And then you're going to take whatever the result is of this floating point number, or double, and divide it by 255 to get a normalized value between 0 and 1, right? So instead of getting 0 to 255, I'm getting a value between 0 and 1, which is the numbers we need, right? Because it's going to be from the values I'm going to get for color is between 0 and 1 for each of the color channels, right? So I'm going to get random numbers for red, green, and blue, and then I'm going to return this as a type of UI color. Remember, that's why I'm extending it. So that's the type I'm returning, and I'm going to return an alpha value. That means the transparency of 100%. So it's going to be 100% opaque. That's what the transparency. That's what it's going to do. This little function. Yes. Well, I need to use and when I'm using an extension, need to use the class keyword because I'm saying add this function to the UI color class. That's what I'm doing.
If you don't add a class in
Okay, let's try it. And let's see what it does. See that? So random color on type UI color. Did you mean to use a value of type UI color instead? It's confused, right? And the problem with it is it doesn't know what you want to do. What I really want to do is I want to add my function to the class, and that's what I'm doing when I do this, right? The built-in class UI color, I'm adding the function on as a plugin. That's what I want you to think about. The extension is like a plugin. It depends on which function you're adding it into. In this case, it's ambiguous if you do it the other way, and that's where you use class, like class keyword, right? All right. So, but it's kind of, again, a really neat effect. Like that's one part of Swift that I really like the fact that you can actually extend a class that way. Some other languages do it differently. You can like, for example, some languages support mix-ins or other kinds of ways of extending a class as opposed to creating a whole subclass, right? Subclassing is bad in some ways. Okay, so so these are the three first parts. This right here is going to be used in the entire application, right? So my Quartz Fun View UI view that I'm using, and remember, what is this UI view? It's whatever I'm drawing on the screen, right? Whatever shape I'm drawing, that's the UI view that I'm returning back to my my view controller.swift, right? So I got a shape, some kind of color, and am I using random or not? Then internal properties, things that I'm using the private keyword for, where I'm kind of keeping it internal to the Quartz Fun View file, or UI view, if you will. Image. Notice that I'm using something called iPhone. Why? Because in assets.xassets in this application, you have an iPhone image, a ping image, that's kind of scaled across different screen sizes. All right, so that's what that refers to. Okay, that's what this iPhone is right here. First touch location and last touch location, that's when I do one of these. Here's my first touch location on the screen. Here's my last touch location. So when I slide my finger across, that takes care of in coordinate space where I'm starting from and where I'm ending. That's important because if I'm going to draw a line, if I'm going to draw some kind of rectangle or an ellipse or whatever, I need my starting and ending coordinates. Okay. Redraw rect, right? We're going to talk about what that is. That got added in later. If I want to set my rectangle to 0. Notice 0 is an enumeration again. CG point 0, CG point 0. So that means I set these by default, right? I initialize these two values to 0. It's almost like saying 0, 0, 0. CG point is, and if I have 3 dimensions. In this case, I'm only using 2. So it'd be, X and Y would be both 0 with CG point 0. And same thing go with redraw rect, CG rect 0, which means 0, 0 with a width of 0 and a height of 0. That's what it means, right? So it's almost like a way of initializing these 3 variables. Clear?
Yeah, but that's my thing, that you cannot put it if you want.
I can put in my CG rect of nothing. I can initialize it of something.
You can put actually and work with related coordinates. You instead of, I'm asking, CG points,
Yes.
5.0, can you put instead of 0 and add whatever points before?
Yes, I could. Yeah, and then you can keep whatever you want. You can remember. Remember, because every time I use a UI view, right, I'm just initializing. So when I instantiate a new UI view of this type, which is of type Quartz Fun View, right, when I instantiate it by drawing it on the screen, I'm creating a new location, as an initial location. Now, if wherever I'm touching, I'm doing that shape. Now, here's some interesting parts because this is a UI view, and UI views like buttons and labels and text views and all that kind of stuff, they have sensitivity to touch, right? They know where your touches begin and where your touches move to. I can drag stuff around with my touch, as well as where my touches ended, right? And these functions are built into the UI view class, and we need to override them so we can tell Swift what we're doing. So again, example would be if my touch, I'm defining a variable called touch. If touch is first, and if you notice if I'm using my random color, then my current color is I'm actually calling that new function, UI color. Notice that I'm using that UI color we've defined, my little plugin, right? I'm getting that color right here, right? So whatever that, if I'm using it, then I'm calling it right now. And my first touch location, which is starting off at CG.0, is equal to my touch.location in this object, in self. That's what it means, right? And my last touch location is my first touch location for now, because there is no last touch location yet, okay? Then I clear my rectangle, whatever it was before. If I had it, if I was using it before, I clear it. And then it needs display. We're going to talk about what that is in a bit. Okay, let's keep going here. So again, if I touch moved, my last touch location is my touch.location in self, right? And then depending if my shape is an image, then I'm going to define my image as my width and my height is going to be a set image. Height and width isn't going to change for my image. Else, if it's a rectangle, right, then I'm going to draw the rectangle based on the shape that I'm drawing, right? And then finally, when my touches end, I record the last touch location. That's all I'm doing with these 3 touch events, all right? So one is where am I starting? Another one is, defining the shape of how I'm dragging my finger. And then the third thing is where I'm ending, right? And those things fill up these variables right here, right? First touch, last touch. Okay, cool. Now I'm not drawing anything yet, right? Okay, here's my draw function. So now, depending on my first touch and last touch location, my draw function is part of my UI view that I'm defining. Remember, I'm overriding it. The draw function is part of all UI views, right? So again, part of the button, part of the label, part of all those things, right? And it's being called as soon as I instantiate my view, right? As soon as I instantiate that thing, it gets called, right? So now I'm defining my context, just like it said in the PowerPoint document. I'm saying that my context is equal to the UI graphics get current context. So what am I pointing at? Is my current context the screen? Is my current context another shape somewhere else? I can point to wherever I want with this thing, which is why it's so powerful, right? And then I'm saying the line width. Notice I don't have a choice here. It's not like I have another control that says set the line width to less than 2 or 3 or 4 or 5. I can't. Maybe what we can do today is modify this thing so we can input the line width as something different instead of it being 2. And how would we do that? Here's my stroke color, whatever the color is, depending on the current color that I've selected. And then here's my shapes. I'm using a switch case statement. I'm just going to kind of make it so that you can see it a little bit nicer. Here's my switch case. And now, depending if it's a line, a rectangle, an ellipse, or an image, where am I getting this from? My enumerations that I set up here, right? Line, rect, ellipse, and image. Doesn't mean anything. It's just 0, 1, 2, 3, whatever I've selected, right? And if I go down here, depending on which one I selected, so case, if it's a line, then I'm going to define my first touch location as a CG point. By the way, this is my modification. Just let first point and last point. I had to do this because I wanted to show you what I did. Because remember, this was move to, and this was add line to. They don't have those anymore. It's move and add line, right? So if you see it in your book, if it says move to and add line to, no, it's move and add, right? Move and add line. And then stroke path. Stroke path draws it. It says, okay, I'm drawing a line. So start from this first location at the first touch location and go to my last touch location, wherever it is, and draw the line. And then in case if I'm drawing a rectangle, well, you know what? Current rect. Where is this current rect? Well, it's down here. We're drawing a rectangle. It's another little function that we're using. And we're getting again, a CG rect, where we're getting our first touch location, right? For X, the X coordinate of our first touch location, the Y coordinate of our first touch location, and then we're using the last touch location minus the first touch location to calculate the width. And the same thing goes for the height. And then we're using that to draw that rectangle. Well, that's the current rectangle we're drawing, right? So we get that current rectangle here, depending on what the first and last location that we're touching is, and we're passing it into the add rect method, right? For the context. We're saying, okay, add a rectangle to my drawing surface. That's what this is doing. I haven't shown it yet until I use draw path. When I draw path, I physically draw the rectangle. So first I define my path, then I draw my path. Okay, yes?
What happens in this function? I'm used to AutoCAD. So when I start, instead of draw a rectangle in this way, I do the opposite. So the first coordinate is going to be bigger in number. The value is going to be bigger in value than the second.
Let's try.
So it's going to be.
Let's try. Right. So if I mean that means I can't draw up. You mean, or I can't do a rectangle up. Something's going to happen, right?
No, it's going to be a negative value. As it works.
Yeah. Okay. Now here's something different. The what's the fill? How come there's no fill? How come there's no fill here? It's black. How come it's black? I didn't define black in my rectangle. How come? How come it's black? Because that's the default value. Okay, let's change it. Let's see if we can make the fill, right? So we did a stroke. Remember in the PowerPoint, here's the PowerPoint right up at the top here when we're defining a shape. It's one of the first things we looked at when we're defining it. In the PowerPoint, we had this little bit of code that said, let's add a stroke color, right? We can also add a fill color, right? So the same way, context.fill color. Let's see if we can do that, right? So here's our add rect. And before we add the rect, we want to define a fill color. Notice that up here, we define a stroke path. Here's our add line, right? And where do we find the stroke color? It's up here. So why don't we just define the fill color if we need to down here, right? The same way. And we'll use the current color. So whatever the current color is, we'll make it fill up everything, okay? The same way. So I'm going to copy this line. And I'm going to go down to my rect only. And before I draw my rect, I'm going to come up here and paste it in. And instead of the stroke color being what it is, I'm going to change this to the fill color. Let's see if that works. So set fill color, right? The fill color to this color, CG color, which is right here. Let's get rid of this. Let's see if that works. Stop doing this, and we'll run it and see what happens. See if it runs, first of all. Did I do something wrong? Let's see what happens now, right? We got this, no problem. When I draw a rectangle, I want to draw the color now, right? Now it's not black anymore, right? I mean, like literally, guys, that's how simple it is to do this kind of stuff, right? It's intuitive when it comes to, and I'm drawing it backwards just for you, right? Just because you asked. In fact, I'll even do it this way, like even works that way, right? And the same thing goes with here. Green. It's kind of, you can see a little bit better than before, right? And here's my random colors. Let's see what kind of random colors I get here. I mean, what I do, right? I always get random colors. Right? Nice colors. Mona, we can draw our scene the way we want to now. That's it. We can draw our ocean and you know, the sea, right? All right, so that's what this does. So whenever we decide whatever we're drawing, depending on what we're choosing, we're going to get a value 0, 1, 2, 3. Where are we getting these values from? Our segmented control. It starts off at 0, 1, 2, 3, depending on what we're choosing. We're going to send that value in here, and depending on which one we're choosing, we're going to use that as the same value that we're using in our enumeration. Okay, so we're actually getting a 0, but I'm actually listening for a dot line because line means 0, right? Here's our ellipse, and we have to do the same thing. If I want the fill color to work for our ellipse, then I would do that here as well, right? How about if I want another color instead of my current color, CG color? Can I define all my ellipses? I want to make them white. What would I do? How would you guess I would make that happen? How can I make this current color is a CG color, right? That's what it's listening for. Look. So if I was to do this, my fill color, if I open this up, right, it's looking for a CG color that I'm looking to kind of add in here, right? That's my set fill color, right? So I wanted to find a color. How do I do that? Right, well, notice in my PowerPoint, if I go back to my PowerPoint, it says my CG color is UI color dot red dot CG color. Let's do the same thing. Let's see if I can do that. So I'll say UI color, right, dot white dot CG color, right? And if I'm good, if I do this correctly, then when I run my code again, when my ellipses are all going to be white. Am I right? Yes, you're shaking your head. You're like, no, it's wrong, right? Let's see if I'm right. By the way, notice that there's a difference from using the unwrapped version. So just choose ellipse and then white, right? Oh, there's some weird issues going on here. What's going on here, right? Well, because the way the stroke size, right? I am getting a white, and if you notice, if I come up here, it's drawing right on top of my buttons too. See? Because my context is the entire screen. I didn't define a context that's smaller. So anywhere on the screen I can draw, including over my controls, because who cares? It's just a UI view, right? Well, okay, cool. What about if I wanted to make my stroke, my line width bigger? Let's make it 4, just to experiment. Try this out. Yeah. I'm really like impatient with you know, the building, the debugging, right? All right, cool. So we'll draw a line, nice and thicker, right? And we'll draw an ellipse now. We'll make that ellipse much bigger. You can see now that it's a much more defined line. It's very easy to figure out. It's not like it's that difficult to figure out what all these things mean. Set line width actually is a very intuitive, you know, way of thinking. By the way, why is it intuitive? It's not Swift. It's C. That's why it's so intuitive. Because if it was Swift, it'd be called some other weird thing, right? I'm sorry, Apple, if you're watching, right? But it's just the way it is, right? C stuff is just so much easier in some ways, right? So yeah, so set fill color, add rect. We did this. Draw path actually draws the path. So if I take one of these things away, so let's say, for example, I don't draw the stroke path from my line. So I'm just going to comment it out, right? So I'll comment this part out. Remember, so I have to do this last line to generate the line the path that I'm drawing. So if I don't do this, so if I stop, and if I try and draw lines again, it'll build. It's going to do what I told it to do. It's going to actually move my invisible pen around, but it won't draw the path unless I tell it to. So here's my line, and now you can see that I'm not getting anything, but it's actually doing it in the background, right? Just not drawing anything right now. Okay. However, when I draw my rectangle, no problem, right? So that's what this does. Okay, so that's really the new class we had to define, this UI view. We extended the UI view that's built in, and we just called it Quartz Fun View. You could have called it Custom View or whatever you wanted to call it, not a problem. How do we implement it from a view controller perspective? Well, first of all, if we look at our main storyboard really quickly, I'm just going to double click here to save some space, right? There really isn't a lot to it, truly. Just a couple of segmented controls, but notice that there are 0, 1, 2, 3, 4, right? So 4 different sections there, and there's 5, and there's 0, 1, 2, 3 here, which aligns with this stuff up here, right? 0, 1, 2, 3, 0, 1, 2, 3, 4, and that's how it's going to be looking, okay? But again, it's important to understand how this is made. Okay, so we need to IB actions, right? In order for us to, whatever, depending on what I'm clicking, that's the first thing we need. Somehow these controls are going to set the values for my UI that I'm drawing, my UI view, okay, from here and here. Okay, let's take a look at the regular view controller.swift, which is right here. Okay, so here's my view controller.swift. And notice I have a couple things. I have a couple of IB outlet references for my color control and my shape control. By the way, I don't need this, but it's there anyway. I put it in. My view did load doesn't get touched, nor does my did receive memory warning because I don't care about that stuff. But here we go. Here's another, change color. And how am I getting this information, right? Well, I'm using another switch case, right? And I'm switching my drawing color, and I'm saying, well, let my drawing color equal to my drawing color selection. Okay, I like that. Where my drawing color selection is the drawing color as a raw value of whatever my selected segment index is. So again, index of my selected segment, 0, 1, 2, 3, or 0, 1, 2, 3, 4. It's going to take that because it doesn't care which one it is for my change color. In this case, it's 0, 1, 2, 3, 4. And I'm using the same enumerations, so I don't have to remember what they are. If it's red, then make my UI color red. If it's blue, make my UI color blue. And then set them into my fun view, which I'm actually just, creating a new view, right? Here it is right here. It's my Quartz fun view. I'm setting it as a view, right? Here's my new view as this Quartz fun view, my new object, right? And depending on my color, I'm going to set the color of the object, all right? Right away. That's the first thing when I select it. Okay, cool. So I've got my object, my fun view, right? And what does this return? My change color, all it does is select, right? I select my my color. And here, shape selection does this exact same thing. I set up another fun view as another Quartz fun view, right? And I get the shape, whatever shape I want. Notice that the color control is hidden, is equal to the shape, is equal to the shape image if there's an image. Okay, don't worry about that. Okay, cool. So I've got those things. Okay, but how do I draw stuff? Right? How the heck is it being drawn? Right? Because all I'm doing here is these let statements, they're constants that are being defined within my change color. How is it that I can draw with this stuff? Right? Well, here's what happens, right? As soon as I instantiate, if I click one of those buttons or whatever, or even if I don't, right? It doesn't really matter. Because my class is there and it's being, selected, my change color. An example of this would be if I go back to run my application again. Let me just run this again to show you. Yay, I'm running. Okay, I haven't selected red. How come why is it that my UI view is being triggered right now? I haven't selected anything. How come it's happening? Come on, think about this, guys. What's happening with the life cycle of my application? What's really happening, right? As my view loads, what happens? I have a default value selected. When it gets selected, it triggers an event automatically. Because my event is triggered, it creates a UI view, and now I can draw to it. Okay? That's how it works. So I don't have to do anything. I don't have to do any of these things. I can still draw lines, right? Because, right? Depending, doesn't matter whether I select something or not, it automatically gets selected for me. Okay? And when it gets selected, that means it triggers or raises an event. That's what we want to say when we talk programming, right? If I go to my view controller.swift, it raises these two events. It raises my change color event. When my change color event gets raised, right, I define a fun view, which is that view, whatever it is. And hey, here's a question. Which one gets raised second, right? Is it this one or is it this one? How does the view get drawn? Because it gets drawn from the top left, and I'm actually adding things in. Which one gets accessed first? This one or this one? Or does it happen at the same time? Color goes first, which means I define my color, right? That's the default color that I set to the view, right? And then at the same time, here's my shape. My default shape is whatever the shape is that I've selected, which is a line. Right? Because that's what I've selected, the line shape. And I got the color already, right? Now here's the conundrum. How, if I'm using a view, this fun view that I'm declaring over here, how come, just saying, right? When I'm defining it here as a Quartz fun view and I'm switching the color, how come the color doesn't, like, what's the default color? Is there a default color anywhere? It's got to have something, right? Think about it. How does it know that my default color is going to be what it is? Right, it's going to be 0. Let's take a look. Let's go back to this, right? So, okay, here's my UI color. I'm doing my random color. Cool, cool. Oh, man, look at this. It's right here, right? That's how it knows, right? If I change my default color to something else, right? That's my default color black, right? Show you what this thing is. So I haven't selected anything now, right? So because I haven't selected anything, it should be black because that's what I've set my default color to. Just to get you an idea of how this whole thing works, right? Because my UI view is going to be generated twice. Once for the top segmented control and one for the bottom one. Depending on which one I choose, I instantiate a new UI view control that I'm going to use, right? Now, it's going to be black, even though it says red, because that's my default. That's what I said inside my UI view control, right? Need to start from somewhere. Because this is being generated second, this is being triggered second, that means the second one is being triggered, so my line is my default shape, right? Because I'm triggering this second. Both of these segmented controls are being triggered, both of them, right? But the second one is being triggered second, and so therefore that's going to be the default view, right? I know it's hard. If you don't know this stuff, then it's hard. But why are we doing this? Because one of your assignments coming up next week, you're going to make your own programmatic views is what we're going to talk about, right? How to create your own views programmatically without using any kind of drag and drop. Your storyboard will be blank, right? Which is important. You have to know how to do those things because you have to be able to draw to the storyboard without using drag and drop, right? So that's going to be one of your assignments coming up. Okay, so let's take a look at this. So when we look at your change color again, let's go back to my Quartz view, where I changed, right? And this is sorry, I'm looking at the wrong thing. I changed this to black, right? So remember that the default was red. And the reason why the default is red, my UI color red, is because in my controls, the first color that's by default red is what it is. And we kind of matched it up to that. Okay, we made it so that this is red. Now, wouldn't it be nice, just putting it up there to you guys, does anyone know how to change these to different colors? So instead of it being all blue or the background all red or whatever, is there a way to do these different segmented controls so that this looks like red, this is blue, this is yellow, this is green, and this is something else, maybe another color, or maybe just random, like it says here, right? Does anyone know how to do that? That's pretty ugly. I mean, red, blue, yellow, green, it's like kind of ugly drawing. Do you know how to do it, Mona? No? Let's see if we can do it in the control. A lot of this stuff, when it comes to segmented controls and other kind of built-in controls, we have to program them to do that, the functions, right? They don't kind of, there's nothing in Xcode that allows us to do that, which unfortunately is the way it is, right? So let's take a look. So I'm kind of going to go into my main storyboard for a second, and I'm going to zoom in on my my segmented view up here. I'm going to kind of click on there, bring this up here, and we're going to look at the inspector over here for my segmented control. And does it seem to be a way that you can see, there's the tint for the whole background, right? There's the tint, right? And you can see that the width, and I'm using my gamut. Here's my gamut value, right? Which is whatever I want, any, right? And I can choose a different color mode, if you will, right? My width is compact or regular. My height is compact or regular. This defines this control a little bit here for tint. But when it comes to color, it's all one color. So if I change this to something else, like green, then the whole thing is going to be green. And I don't want that, right? I want each individual segment to be a different color. How do I do that? Where's the segment? So I can double click on it. So there's my segment, right? Double clicking will give me access to changing the title, right, for the segment itself. And notice that the segment says red, blue, yellow, green, random, and they're also numerically ordered, right? That's why segment to control in this case is a good option, right? So there's 5 segments, right? And now you have to change the number from I think it was normally 2 to 5, right? Here's my style, which is plain. I can go make it bordered, right? I can make it a bar of some kind, different kind of way of looking at it. But at the end of the day, it doesn't really matter, right, in this particular case. So here's my segment to control. If I go to bordered or if I go to bar, right, no difference. So tell me, what can we possibly do to change this? There's also an image. I don't want this. It's the iPhone image. I don't want that, right? But I could make it so that I want to make it so that each one, here's my content mode, scale to fill, right? Aspect fit, redraw, center, interesting, the way it's drawn. Here's my tag, if I want to associate a tag with it. Here's my interaction, here's my alpha value. If I make it so it's different alpha value, it means I can fade it out, right? Or bring it back, right? So I can make it 100% transparent or opaque, right? Come on, what else is there? How else can I do it? How else can I modify these each individual segment? Sorry? Programming, yeah. So how do I do the programming? How do I access the segment to control through programming? So if I go back to my view controller of Swift, I have access to my segment to control through my color control or my shape control, right? So if I want to modify it, and let's say, for example, I don't know, when my view did load, right? Here it is in here. I want to change my color control. Okay, let's see. Color control. Got. And let's see what else I can do here. I can change a bunch of things, but that doesn't really help me. Oh, here's some sets, image, and enabled, and title. I want to talk about the segments, though. Is there some way of modifying my segments somehow, right? Because I have to get access to those segments, right? What about if I wanted to just change the name of the segment, right? I mean, I should have access to that too. And if I can get access to the segment, that means I can have access to the values as well. Or here's the other option. Do I have to create a new custom segmented control that I have to modify on my own? Is that what I have to do? Let's take a short break, and when we come back, I want to find out. I want to see what we can do with our segmented controls. Part of this day today, by the way, before we take a short break, is I need to talk about, because the second part of this course, first part was really kind of catching you up on things you needed. Hopefully by now you're up to speed. And if you're not up to speed, or if you feel uncomfortable with Swift and iOS still, you should talk to me about it before the end of class, or by the end of class, because it's not going to get any easier, right? I'll be honest, right? This is where things are going to get a little bit more interesting, especially next week when we do more stuff. So you need to talk to me about this if you feel really uncomfortable, because we're going to keep moving. We're going to keep pushing here, right? Do I expect you guys to be experts? No, hell no. I mean, it takes years to be really good with iOS programming in general, and because of the way there's so many different aspects to this whole thing, right? But I also want to talk about another thing. One part of what we're doing here is I'm preparing you for doing things for your capstone project, right? So one of the things in the capstone project is there anybody doing any kind of cross-platform stuff? Like, for example, with both iOS and Android. I know if someone mentioned they were doing both. Anyone doing both applications? Only one? Are you guys doing both? Yeah? How are you doing both? Like programming Android and iOS separately? It's crazy, right? So I'll give you some alternatives. Now, I'm not going to talk hybrid apps. That's Shemik's option. That's definitely an option for you guys. If you want to do both, you can use hybrid apps. Because remember, we're making a prototype here. Do we expect you to make a full-blown app? Hell no, right? There's just no time, right? But the other option I'm going to give you is to use Unity to create your app, right? As opposed to using Xamarin or some other hybrid app platform. So we have to talk about that a little bit today. I'm going to introduce Unity to you guys, not for making games necessarily, but for a cross-platform creation, right? So how do we do that? Okay, so let's take a short break. When we get back, I want to fix this problem. I want to make my my segment to control maybe either a custom control, or I want to think about making modifying some things in the segment to control. Let's figure that out together.